Warm welcome to all the students. In this lecture, we are going to see how to implement Runnable interface. Runnable interface is just another way of creating a thread. In our previous lectures, we have already seen using a thread class in the package java.lang. Okay, we can create thread, and now for this lecture we shall see how we can implement this Runnable interface to create thread. This is a second way of creating a thread. Thereafter, we shall see what is inter-process communication and how this is carried out between the different threads. Implementing the Runnable interface, we know that we can create thread in two ways. One, using extended thread class, which we have seen in the past lecture, and by implementing the Runnable interface. So we shall now see how to make use of Runnable interface to implement the threads. Notice that this Runnable interface, it declares the run method, and this run method is required to be implemented by whichever class that we are creating, which will implement this interface. To do this, we must perform the following steps. 1. Declare the class as implementing the Runnable interface. So the very first line, suppose I am creating my a class, let's say my thread. My thread is a class that I want to create. So I will have to declare my class as class, my class implements Runnable. Then this Runnable interface, it has a run method. So I will have to implement this run method in my class. And third, I will have to create a thread by defining an object that is instantiated from this Runnable class as a target of the thread. Finally, call the thread start method to run the thread. This is simple program that I have created. My class that I am creating is called as my thread. I am just saying my thread implements Runnable. So the class that I have created, user defined class, now implements the Runnable interface. This Runnable interface, it has a abstract method called as run, which I need to define in my class called as my thread. Now how do I define it? So I am saying first it is going to print a message on the computer screen that thread X started running, and then for I equal to 1 to 10, so for 10 iterations it is simply going to print thread X iteration number. So every iteration, whatever is the number, that is going to be printed, and once this task is over, it is going to print the thread X ended. So this is basically the code, right? And this is the end of my class. Now in main, remember students, since you are implementing Runnable interface, the very first thing what you need to do is, since my class is my thread, first to create an object of the class that you have created. So my thread is the class that I have defined. My obj is the object of that class. Next, you shall create an object of type thread. Now what is this thread? Thread is the thread class, inbuilt thread class, which is there in java.lang. So you need to create an object of that thread class, and the object that you have created of your own class, that is my thread object called as my obj, that you should give it as input to the constructor of the thread class. You should always remember this two steps, because this is how you will implement the Runnable interface. So the very first thing is, you should create an object of the class that implements the Runnable, and that object is my obj. Then you also create an object of the thread class, which is an inbuilt class which is present in java.lang, right? That object is thread obj, and in the constructor of that thread class you shall pass the object of your own class as an argument. Then using the object of the thread class, you shall call the start method, and you know that the start method internally will call the run method, and it will implement all this. Once everything is over, you shall print here just before the closing bracket of main that the main thread ended. Okay, now when you run this program, okay, you will see the following output. Okay, you see that the main thread ends, right? So what has happened here is, after doing this particular activities, here you are making this thread obj runnable, and just after that you see that the main thread is ended. Okay, then your the object thread obj gets the control of the CPU. So run method is executed. So you see that thread X started running, and you see each and every iteration getting printed, and once this is done, thread X ended. Inter-thread communication. The exchange of messages between two or more threads is called as inter-thread communication. Now when does this happen? The transfer of these messages take place just before or after the change of state of any thread. Okay, for example, if there is an active thread, this active thread may notify to another suspended thread just before switching to the suspended state. Okay. Now how Java implements inter-thread communication? It does so with the help of the following three methods. One, notify method. What this notify method does is, it resumes the first thread that went into the sleep mode. Suppose there are many threads which are in the sleep mode. Okay, it resumes the very first thread that went into the sleep mode. The object class declaration of this notify method is as below: final, void, notify. Second method is notify all. This method resumes all the threads that are in the sleep mode. Now since there are many threads in the sleep mode, the execution of these threads, it happens as per the priority. Okay, so whichever is the highest priority thread, that will be resumed first, and so on. The object class declaration of notify all method is shown as below: final, void, notify all. And the third most important method is wait method. This method sends the calling thread into the sleep mode. This thread can now be activated only by notify or notify all methods. One can also specify the time for which the thread has to wait. The desired waiting time period is specified as an argument to the wait method. We shall now see a program. Before that, we shall see how is the object class declaration of the wait method. So it is final, void, wait. Remember, all the above methods are declared in the root class, that is the object class. Since the methods are declared as final, they cannot be overridden. All the three methods throw interrupted exception. Let us now see an example program. I have a class called as circle. I have declared a radius, initialized it to 0.0 floating point value. I have two methods in my class. One is synchronized void output, and second one is synchronized void input. Okay. Now I have used a keyword called as synchronized. We have already discussed why synchronized is used. That is because if there are two threads which are competing to access the same method, okay, then if one thread accesses a particular method, the other should be stopped from accessing it, right? And only when this particular thread releases the method, only then the second waiting thread can access the method. And synchronize is basically the keyword that is, make sure that it is synchronized. Two threads at the same time does not access the same method. Okay, so we have output method. Now what this output method does, first it prints a message on the computer screen that output method invoked for displaying area of a circle. Now if the radius is 0, that means it is still 0, the input has not come yet, then it simply prints that it is waiting for input radius. And since it is waiting, the current thread who has got access to this output method, it goes into the wait state by calling the wait, right? Again, see, I have used a try block and catch block for the wait, right? So this is the output method. So whichever thread gets an access to this method or calls this method, it will first print that output method invoked for displaying area of a circle on the computer screen. Then it checks if the radius is 0. It will print on the computer screen that it is waiting for input radius, and that thread is now going to wait. How much time it is going to wait? Till notify signal is given to it by the other thread, right? So once it starts waiting, other thread which was in the wait state now starts execution. Okay. Now once the radius is received by this particular method, okay, not 0.0, some other valid value of radius, okay, it simply prints a message that area is 3.14 into radius into radius. So this is basically the output method. There is another method called as input method. Now what this input method does is, it simply prints on the screen inputting radius. Then you see that in this input method we are also passing a radius from void main. So that radius r is assigned to the radius variable, and it simply prints a message on the computer screen that yes, the radius is now received, and it gives the notify signal. So notice that one thread, okay, who had caught hold of this output method, after reaching this point here, it realized that input was not given. So that thread, okay, it gave the wait command. It sent this wait message to the next thread, and it said that yes, I am waiting, I want input radius value, I have not got yet, so I am waiting, can you please give me? Once this wait signal is given, if the second thread, okay, who is in the yet to get the resource, if the second thread, it calls the input method, that second thread will do what? It will get the input from the main, and once the input radius value is already obtained, it is going to simply send notify message to the previous thread which is currently in the waiting state. So this notify method tells that yes, I have just made sure the radius is entered. Okay, I am now waiting. I am notifying you that you can continue your work. So once the thread which was waiting, it gets this notify signal, it continues its processing, and it goes ahead and it says that area is 3.14 into radius into radius. Okay, so we have two methods, one is output method and one is input method. Note that I have written both methods with synchronized keyword so as to ensure that since there are two threads and two threads at a time may compete for the same method, calling the same method, so in that case there could be a problem. So I am making sure that at a time only one thread can get hold of a method, okay, and when one particular thread is holding a particular method as a resource, other threads should not be able to get the access to that method. Okay, so this is synchronization that I am ensuring. It is very essential for inter-process communication. Now let's start. So this is my public static void main. I am first creating object of class circle. Why this object is necessary? Because it is only this object that can call either the output method or the input method from the main. That's why this object I have created. Now here I am creating a new thread. Now you see I have not given any name to the thread. I am just saying new thread. Okay, you could have also said thread t new equal to new thread. You could have just given the name to the thread. By writing the new keyword, what is happening is a new thread object is created on the heap. Okay, now every thread has a run method, right? So I am defining the run method within that new thread. In the run method, using the object C, I am calling the output method. So what has happened is when the interpreter it sees that new thread has been created, okay, when it tries to run that particular thread, it sees that, okay, what happens, what this thread does is it accesses the output method. this thread, it accesses the output method through the object of that class. Okay. So once the thread starts running, that thread will do what? That thread will access the output method. Okay. And then after creating this thread, we call the start method. So start method will do what? It will make the thread runnable. Okay. Once the thread gets the resource, that is CPU, this start method internally automatically will call the run method, and as a result this thread, it starts running. Okay. Now once this thread starts running, okay, object C calls output method. So basically this thread, the current thread, is now calling the output method, this method. Okay. So first you will see that the output that you will see that output method invoked for displaying the area of a circle. This message will be printed on the computer screen. Then this same thread, okay, who is currently holding this output method, when you go to the next line, it sees what is the radius. So far radius has not been entered. Why? Because the input method is not called by any other thread. So as a result, radius is still 0.0. So the thread finds out that the radius is still 0.0. That means it is just initialized. We have not got any value of radius from the input, right? So it prints on the computer screen that we are waiting for input radius, and this thread, it gives a wait, it sends the wait message to the other thread. Now which other thread? You can see in the main there is another thread which we have created, and this thread, in its run method, it calls the input method, and it is passing a parameter, a valid value for radius, that is 2.5 floating point value. Okay. So this thread, which is now running, after finding out that the radius is not yet given, valid radius value has not yet been supplied from the input, okay, it sends a wait message. It communicates to the other thread saying that yes, I am waiting now. I am waiting so that you can give me the input value, right? So now what happens is the next thread, the new thread, okay, as you know, the start method is invoked. The new thread, what it will do? The new thread now executes its run method, and it calls the input method. Okay, so object C is calling input method by passing 2.5 floating point value. So input method is called by the second thread, whereas the first thread here is still waiting. It will wait till notify signal is passed by this second thread. So second thread accesses input method, 2.5 gets copied here, right, and then it prints inputting radius, where R that we pass from the main is assigned to the radius variable, and finally it says, okay, system.out.println, it prints that the radius value is received, and then it passes a message to the thread which is still waiting for input, that notify signal it passes. It notifies the second thread that yes, I have given you the input now, so I will stop now, I will wait now, you continue your processing. Okay, as a result, this thread which had stopped, where it had stopped here. After receiving the signal called as notify, it continues its processing, and the last statement is printed on the computer screen. That is, area is, it multiplies 3.14 to the radius that is just received into the radius, and that's how you get the output. So this is how two threads, they communicate with each other. Now students, please note, in public static void main there is a main thread, correct? So when interpreter, okay, when Java interpreter starts execution, first an object of circle class is created, then the new thread is created and it becomes runnable, then another new thread is created, it becomes runnable. So at this point, main thread has finished its execution, and at that time there are two threads which are runnable. Okay, two threads which are runnable. Then one of these two threads, that is this thread, it gains the CPU, and that's how the output method is called. But then it realizes that radius is not yet given as input, so it gives a wait signal to the second thread saying that I am waiting, you give me the input. that activates the other thread, second thread, which is also runnable, to enter into the running mode. So then the second thread runs and it supplies the input, calls the input function, and whatever is the input radius supplied, that is stored in radius, and then the second thread, it gives the notify signal to the first thread which is waiting, saying that yes, I have given you input, now you can resume your work. Okay, I have done my job, I am waiting. So the first thread, it had stopped here, it comes out of the waiting state, again back to the running state, and it continues running, and that's how it gives you the output. Okay, so when you run this program, you can see that the first thread, after calling output method, it says output method invoke for displaying area of a circle. Then since radius is 0.0, it says waiting for input radius. The first method is now in wait state. The second method is notified regarding that. Second method calls the input method. Second thread calls the input method and says inputting the radius. Then whatever radius is passed, that is stored, and it prints radius is received. And then the second method, second thread, it gives the notify signal to the first method, saying that yes, I have given you the radius, please continue your work. So then the first thread again resumes and it prints the area, that is 19.625 in the computer's screen. So this is how inter-thread communication works in Java. Suspending, resuming and stopping the threads. These are some other functionalities that you can have with threads. However, from Java version 2 onwards, these are deprecated. They are removed. Why? Just to prevent the occurrence of deadlock and system failures. What is deadlock? We have already seen in the past lecture. Now, notice that when you abruptly stop some thread, or when you abruptly suspend certain thread, okay, there is a possibility that a special condition called as deadlock can occur, which can ultimately result into system failure. So these methods, although they were there in Java, from Java version 2 onwards, they have been removed just to prevent the occurrence of deadlock and system failures. So we shall not be discussing these methods. Okay, so this was a brief overview of how multi-threading is basically carried out in Java. Thank you.